Okay, I just wanted to create a little how-to video of Desmos for those who have never heard of it or who haven't used it before, just to explain a little bit better some of the benefits of using Desmos that I mentioned in my presentation. So the first thing up at the top here, we have create account or sign in. So Desmos is linked to the Google's for Education apps. And so I'm going to sign in with Google. And because I've signed in before, it linked right away. And so now I am signed in, which now that we come over here, we have this save option. So students can save their graphs. I'm going to rename this right now. I'm talking about conic sections, so I'm going to call it conic sections. And so as you're doing multiple day projects, students can have their graphs saved and come back to what they were working on the day before. So one of the big benefits I mentioned about Desmos is that you don't have to write equations in y equals form. So for beginning algebra, y equals is very helpful. It kind of gives a format for students to work with. But as we move into higher level algebra, in conic sections particularly is the unit I'm focusing on, the y equals format takes away some of the patterns, takes away some of the connections that students are able to create between the equation they're seeing and the image they're seeing. And so by using Desmos, we're helping students create those connections and hopefully apply what they've learned to a new situation. So for example, if we just make a circle, so circles are y squared plus x squared equals the radius squared. No capitals. So y squared, I'm using the keyboard here. We also have the buttons down here, which I think students actually like a little bit better. And then on an iPad, this is their only option for typing. Plus x squared equals, I'm going to do 5. So radius squared would be 25. If your graph is a little too big, you can zoom out, make it fit a little better in the space. And then we can even play around, move our circle left and right by adding or subtracting numbers. And even just the ability to kind of move around on the graph is nice. It's easy to quick fix a mistake or add something you forgot in. Not equals. So that's kind of how we can move it around. I am going to go take it back to the center because I am going to use conic sections to draw a little picture here. It's not like in these parentheses. A project I've done with my class and I use as a formative assignment, building to a more detailed final assignment, is having students make a smiley face. So pretty simple, and it uses quite a few conic sections, so it's a nice one to have here. So I've got the circle. Some students do an ellipse to make it a longer face, but I will keep mine with a circle here. And then I'll put eyes in, and for eyes I will use ellipses. So Y, and these are going to be a little higher. I'm just kind of playing around here. These are going to be kind of small. I'm going to start with 1. And let's do the same thing for X. So it's nice we can do some copy and pasting, moving around and putting stuff in we've forgotten, and 1. So right now I have a circle again because I have the same denominator on both. So if I want it to be a little oval shaped, I can make this one a little longer, but those are some pretty big eyes. So I'm going to take these both down a little. So we can do that, maybe even something like that. I don't get too picky. I kind of let students do whatever they feel. So I'm going to copy this entire equation and just adjust it so it goes on the other side. And we could have 2 different color eyes. We can change the color here on the side, have our eyes matching. We could also change the outline color. I'll leave it red for now. And then let's put a smile in here. So I'm going to zoom out a little, or maybe even just move it up and zoom in. So for my smile, I think I'm going to do a parabola. So y equals x squared is kind of my basic one, but I know I want it a little bit lower. Let's do down there. And I want it a little bit wider. So maybe something like that. So looking at this, it kind of looks like the Joker right now with that smile going all the way up. So something I do teach my students, and they are going to use later in their final project, is restricting the domain and range. And I actually think this gives them a stronger understanding of domain and range when they think about, oh, I only want to go from this point to this point, left to right, or up and down. So now, as I'm looking at this, I'm thinking maybe from these corners. So I'm going to restrict the domain from -2 to +2. So like that. If we wanted our smile to be a little bit bigger, we could just do it a little wider. Should hopefully have it symmetrical, but it doesn't have to be. So there we've got kind of the outline of our smiley face. We could add some ellipses on the sides for ears. So I would want that centered maybe at 5. Yep. I'm going to start with that. And I'll start with this. So here I've got an ellipse. I want it a little bit more over so I can just kind of adjust my equation. And then I want to restrict it. And we can even use these intersection points to tell me where I would like, or where I need to restrict my domain. So I want the domain for all x's greater than, I wasn't looking at those numbers, 4.876. So now I've got an ear on one side. I'm going to copy this equation and then just change it to the other side and do the same thing. So here I'm just going to make it a negative. And if I do that, I also have to flip the sign around. There we go. So now I've got ears on both sides of my smiley face. We could add hair, we could add irises to the eyes. We can kind of keep going from here. But this is just kind of the basics of how we can use the Desmos to create images. You can also put an image in. So a lot of times when we get to the final project and students are creating cartoons, we'll have them put a cartoon picture in the background, and then it gives them something to kind of trace with their equations, but they still have to come up with the equations to create all the lines. And I just really enjoy Desmos. I think it is a very powerful tool. It allows students to do so much more. Even these domain restrictions is kind of getting into some programming of understanding what you want the image in front of you to do to look like what you need. So just our basics about Desmos here, and just how our conic sections with these y-squareds, every single one of these except the orange parabola, we would have had to do in two separate equations if we were doing on a graphing calculator. And so it creates double the work, and I think it takes away some of the connection and understanding of what students are doing. So I'm going to save this graph. Students can even share the graph. So students can send it to their teachers. They can copy this link to put into a Google Classroom assignment. They can send just the image, which I think they can have the equation show up if that's part of what you're looking at. So Desmos has integrated with the Google Apps for Education, making it very easy to use in the classroom. Thank you for watching, and let me know if you have any other questions about Desmos.